Okay, welcome back. So today I wanted to talk about solving right triangles. Before we do any applications such as angle of elevation or angle of depression problems, it's important to review significant digits, sometimes called significant figures. A significant digit is a digit obtained by actual measurement, and significant digits and the following numbers are highlighted in blue, so I'm just going to talk you through this. You'll hear me referring to these as sig figs, significant figures. You hear a lot of that, I'm sure, in your chemistry classes and other classes you're taking. But 408, that's three significant digits. 21.5, three significant digits. 18.00, four significant digits. So even though those two zeros are after the decimal, they are considered significant. 6.700, four significant digits. So even those trailing zeros are considered significant. Here's interesting, 0.0025. Notice that only the 25 is highlighted. That means note to self. With this one, big note to self. Notice that 0.0025, there's only two sig figs, two significant figures. So that means that those two zeros that come before the 25 are not considered significant. I know that takes practice. Try again. 0.09810. Notice that only four of those digits are in blue. That means four sig figs. So that zero that comes in front of the 9 is not considered significant. And the last one, 7,300. Notice that only the 73 is highlighted. That means only two sig figs on that. Okay? If you struggle with significant figures, you're not alone. Students all over the globe struggle with that. So just practice. Your answer is no more accurate than the least accurate number in your calculation. So as we go through, you'll get more comfortable with significant figures, I hope. Let's zoom in on this. Here, this little table I have. Okay. So to determine the number of significant digits for answers and applications of angle measure, which we're about to do, let's practice identifying the significant figures. So here's just some examples. If you measure something to the nearest degree, like such as 62 degrees or 36 degrees, you're looking at two significant digits there. If you measure something to the nearest 10 minutes or the nearest tenth of a degree, so for example 52 degrees and 30 minutes, that's to the nearest 10 minutes, or the nearest tenth of a degree, you're looking at three significant figures there. So even though that says 52 degrees and 30 minutes, basically the zero in the 30 minutes is not considered significant. If you measure to the nearest minute or the nearest hundredth of a degree, you're going to have four significant digits. And if you measure to the nearest 10 seconds or to the nearest thousandth of a degree, you're looking at five significant digits. So that should help you a little bit in terms of trigonometry land, an angle measure, how many significant digits you're going to have. So, okay, let's continue practicing here. We're about to solve some triangles together. I remind you that when we say solve a triangle, it means to find the measures of all the missing pieces, all the angles and the sides of the triangle. I also remind you that it's a matter of convention that if this is angle B, the side across from it is little b, right? And if this is angle A, notice the side across from it is little a. And we reserve little c for the hypotenuse. So let's just let that be a matter of convention. So letter C is reserved for the hypotenuse. That way we're all making the same drawings across the board, and that no matter what college you go to, that's a matter of convention. So, okay? Pretty standard is what I'm getting at. All right, so let's try an example together. We're going to solve a right triangle given an angle and a side. So when they tell us that A is 34 degrees and 30 minutes, and little c is 12.7, notice little c gets reserved for the hypotenuse of the triangle. Okay? And big A is this angle right here, 34 degrees and 30 minutes. And you say to yourself, how can I get the rest of the triangle? Well, we know, and like I said, I put the answers over here. Don't worry about that. Let's just practice figuring it out. Let's also talk about the significant digits here. So you're looking at 3 sig figs. 3 significant figures for your final answer. Okay? So let's think about SOHCAHTOA. All right? Opposite over hypotenuse. Sine, SOHCAHTOA. Sine is opposite over hypotenuse. So sine of 34 degrees and 30 minutes is equal to opposite over hypotenuse, and hypotenuse is 12.7. Now you know from algebra that you can just take and cross multiply that, and you should arrive at A equals 7.19, approximately. Now, what I encourage you to do, I'm going to hit pause and do that with you. Now, see, I'm under the general assumption that you know how to type in sine of 34 degrees in 30 minutes, like you figured out your calculator. So I'm going to assume that, you know how to type this times this, and you know how to arrive at 7.19. We could hit pause and do that if you like. Okay, so hopefully that worked out for you. Now let's go ahead and think about how to get little b. So we figured out how to get little a. Okay, now let's figure out how to get little b. Well, little b is the adjacent piece to the angle, to this angle that you're looking at. Well, adjacent over hypotenuse is cosine. Okay, so cosine of 34 degrees and 30 minutes is equal to adjacent over hypotenuse, little b over 12.7. Okay, and once again, let's just go ahead and multiply those two values. So I can even, you're literally just going to type on your calculator 12.7 times cosine, that's cosine, of 34 degrees and 30 minutes. Okay, and that's going to be your b. Now, you can hit pause and type that out if you like, but you should arrive at something awfully close to 10.5. In fact, I'll hit pause and type that out and even tell you the exact decimal that I get. Okay, so when I typed it out, I got that b is 10.4664, etc. But notice, notice how with our sig figs, that's going to go to 10.5. So you're going to round that to 10.5. All right? And our last one, I know my notation is, my typing looks weird there, but it should say 55 degrees and 30 minutes. Let's take a moment to figure out how you would solve for angle B. Okay, so now I'm going to put my eyeball here at angle B. I'm even going to draw the eye. Here's the eye. So I have my eyeball at angle B, and I think to myself, how can I solve for angle B? I can solve with some things that I know. What's opposite of angle B? Well, little b. So I know opposite over hypotenuse, right? So I know that sine of big B is equal to opposite over hypotenuse. So 10.5, because remember we had solved for that and gotten 10.5. 10.5 over the hypotenuse, which is 12.7. Now, in a prior class, we talked about if you want to solve for the angle, you got to inverse sine both sides, right? So in terms of typing, angle B would be equal to inverse sine of 10.5 over 12.7. Now I'm going to hit pause and let you type that out. I'm going to assume that you know where your inverse sine button is, not to be confused with reciprocal. So you're hitting inverse sine of 10.5 over 12.7. I'll hit pause. Okay, so I just did that on my calculator, and I got B is equal to 55.76852299 degrees. But the problem is, we want to take that to, we want to figure on the minutes on that, right? So you remember how to do that. So then you're going to hit 0.768, the decimal portion of it, 0.768522299, and multiply that by 60. So now's a good time to mention that when you do that, you're going to arrive at something that does not match the answer key, and that's because of that round off. That's because I had rounded off 10.5. So that's why it says to maintain accuracy, avoid rounding off during the intermediate steps. So in order for me to arrive at what the answer key is saying, let's kind of not use the rounded version of 10.5, so you have to kind of retrieve that. Okay, I'll hit pause. Okay, now this is actually a very teachable moment here. That's why, remember that the 10.5, that's when I had rounded it, with the sig figs of the problem. So when you're actually trying to find angle A, like I said, in order to maintain accuracy, don't use this rounded version that I did. That was sort of, use the full-blown decimal what it was. So what you should actually be typing in is inverse sine of, 10.4, what it was before I rounded it, 10.4664026. Use the big version like that, then divided by 12.7. So what you should arrive at if you don't round, so I'm even going to wipe that out, if you don't round, you'll arrive at B equals 55.5 degrees, but you know that 0.5 degree, half of a degree, is, guess what? 30 minutes. So that's how they're arriving at that answer in the answer key. So that was actually, a teachable moment there when you're doing the calculations to find the angle. Don't use that truncated version that just has the sig figs. And it's funny because I even had a note to myself reminding myself here. So don't use rounded numbers within certain calculations. Use the original raw numbers so you don't compile the error. Okay? All right. I'm going to hit pause and scoot that down and see what's next. Okay, so this is another good one to practice with. We have a right triangle ABC. We are given that A is 29.43, which is labeled. Notice it's labeled directly across from A, angle A, and C, remember C is reserved for the hypotenuse. C is 53.58. Remember your hypotenuse is across from your 90-degree angle. Okay? And we're told to solve the triangle, so that means find all these missing pieces. Now we have the answer key over here. Our goal is to just think about it together. So, all right, well, let's start with just angle A. Well, opposite over hypotenuse. So sine of angle A, and if it helps you, if you're still learning, just keep writing SOHCAHTOA, the acronym, to remind you that sine is the ratio of opposite over hypotenuse. So sine of angle A is equal to 29.43 over the hypotenuse, which is 53.58. Okay? Now to solve for angle A, we're just going to have to take our calculators and hit inverse sine of that ratio. And by the way, we're looking at 4 sig figs for our final answer. Okay? Now here I don't have to worry, like in the last problem I was saying don't use anything that was rounded. Here I'm using the givens, the actual givens that were in the problem, so I don't have to worry about using some prior rounded answer. I'll hit pause so you can type that in. Okay, so when I type that in, I get that A is equal to 33.3170914 degrees. But notice they want the answers, with regard to minutes. So all you have to do is take that long decimal portion and multiply that by 60. I'll hit pause. Okay, so when you take all of this decimal portion here, like 0.317, etc., times by 60, you're going to get your 19 minutes. So there you go. You'll see that, the answer. All right. Now we want to target finding angle B. Okay, so now I'm going to put my eyeball here at angle B, and I know that I have the adjacent piece and I have the hypotenuse. Adjacent hypotenuse. Aha, that's cosine, right? So cosine of angle B is equal to the adjacent piece over the hypotenuse. Now we can know that to get B, angle B, we can just hit inverse cos of that ratio. So we can type that in, and hopefully you will arrive at the correct answer. Oh, and I should have even said, I just realized here that I could have taken you an easier path, of course. If you know C is 90 degrees, which you do, and you had just figured on A being 33, A is 33 degrees and 19 minutes. An easier path, I mean, I'll let you, stew on that, but an easier path would have just, angle B has to be, 90 degrees minus whatever angle A was. Because, I mean, it's got to add up, all the angles have to add up to 180. So another way of saying that is 90 plus your 33 degrees and some change plus this has to make 180. So you wouldn't even have to go through the trigonometry of it all to figure that out. Okay, and then we target little b. Okay, so to get little b, and like I said, here we already have the answer, but to get little b, the thing is, if you know A and you know C, you can just use good old Pythagorean theorem, right? So leg squared plus, and little b is a leg squared, equals hypotenuse squared. See? And then you can just solve for b. So b squared has to equal 53.58 squared minus 29.43 squared. And therefore b is the square root. And I'm just going to put quotes there and let you type that out. So I'm going to type 53.58 squared minus 29.43 squared, and then we'll square root it. And so I'm sure by now you've typed that out, and you arrive at the 44.77, which is right here. So B is 44.77. Okay, hope that helps. Now the final frontier for today is to do some angle of elevation and angle of depression problems. I'm just thinking that I don't like the podcast to be really long, but I think that these aren't super difficult problems. I have one angle of elevation and one angle of depression problem for you. So I think we'll be able to tackle that. Just a little bit of a initial defining here. An angle of elevation from point X to point Y is the acute angle formed. So basically, if you have a horizontal, your angle of elevation is always from the horizontal, okay, to your terminal side. All right? And your angle of depression is also, in between the horizontal. It's the acute angle formed between the ray of interest. So it's the acute angle formed by the ray XY and the horizontal ray with the endpoint X. So, that might not initially make sense, but when we start looking at these sketches, we'll know. Be careful when interpreting the angle of depression. Both the angle of elevation and the angle of depression are measured by the line of sight. This is the good way to say it. The line of sight and the horizontal line. So make sure you're always looking between your line of sight and your horizontal, and then you'll know you did it right. So we're going to work on drawing a sketch with each word problem we're about to do. Use the sketch to write an equation, solve the equation, and check that your answer makes sense. Okay, let's scoot this on down. Here's an example of an angle of classic angle of elevation problem. Okay, you even have the answer there, but I'm not so concerned about the answer as I am about the work. So Pat knows that when she stands 123 feet from the base of a flagpole, so right away, like you're drawing the flagpole, okay, she's 123 feet from the base of the flagpole, and the angle of elevation to the top of the flagpole, see right there when they speak of the angle of elevation, that's this right here. See, it's from the horizontal to the line of sight. If that helps you, you can even write this here as your line of sight. Okay? So the angle of elevation is 26 degrees and 40 minutes. That's this angle right here. If her eyes are 5.3 feet above the ground, find the height of the flagpole. Well, that business about her eyes being 5.3 feet above the ground, we can actually kind of throw that in at the end, and you'll see what I mean by that. All right? So just know that, the distance from here to here is your 123 feet. Now let's think about, angle relationships. You're interested, by the way, and always label what you're interested in. You're interested in the height of the flagpole. Let's call that X. So you're interested from here to here, height of the flagpole. Well, opposite over, you have the adjacent piece, the adjacent side to the angle. Opposite over adjacent, that's tangent, right? So tangent of 26 degrees and 40 minutes is equal to opposite over adjacent. Now you know that you could just type this out on your calculator, cross multiply it with 123, and you'll have X. So again, I'll hit pause. You're just typing 123 times tangent of 26 degrees. But know that that's not your final answer. But I'll hit pause as we do that. Okay, so when you type that out, you're probably arriving at 61 point, about 61.77 for your X. But what was your X? Your X was your distance from here to here. So I always go back to my picture. Your X was your distance from here to here, which is, about 61.77. But notice the answer is 67.1. Well, now if you think about it, remember that 5.3, her line of, her eyeball, was 5.3 feet above the ground. So you have to take that into consideration. So really, that means that flagpole was taller, right? So we're going to add 5.3 and see where that gets us. And that ought to do it, right? So if you add the fact that, we were taking that from her eyeball, but her eyeball was so far above the ground, that means the flagpole was really taller. So you have to add those two together, and that's where you're arriving at that 67.0729, etc., right? So that's why you see the final answer is 67.1 feet. So that's rounded. So we'll round that to 67.1 for our three significant figures. All right, hope that helps. That was a classic angle of elevation. Makes sense that we're going to look at angle of depression next. Okay, last one for tonight, guys, I promise. I'm sure you have a math buzz by now. Finding an angle of depression. Now notice the author's nice here and gives us the picture. From the top of a 210-foot cliff, it's harder when you have to draw the picture yourself. David observes a lighthouse that is 430 feet offshore. So notice from here to here, that's 430 feet. And here's my cliff, my 210-foot cliff. Okay, so I'm observing, I'm just going to draw, here's the eyeball. So I'm observing the lighthouse. It says find the angle of depression from the top of the cliff to the base of the lighthouse. And again, I like to put this is my line of sight. I'm going to highlight that in red. Okay, so here's your line of sight. Remember that your angle of depression is from the horizontal. Note to self, here's the horizontal. It's from the horizontal to the line of sight. So here's your angle of depression, and that's what you have to find. Now, I have the answer here, but I want to think through that. Okay, well, what's happening here is that this line and this horizontal line are parallel lines, and your line of sight is in essence a transversal. So this angle and this angle are alternate interior angles. So they are equal. So therefore what we'll do is we'll just target this angle, and we'll inherently know then the angle of depression. Again, the angle of depression, so in words, I'm just going to write angle of deep for depression, is congruent to angle B. How come? Because they're alternate interior. And so we've talked about that before, so alternate interior angles. All right, so if we just target angle B, well, what do we know about angle B? Well, let's see. Here's the opposite piece. Here's the adjacent piece. Aha, tangent. So we know tangent of angle B is equal to opposite over adjacent. Now, to solve for angle B, we're obviously going to have to hit inverse tan of 210 over 430. All right, I'll hit pause as you do that. Okay, and hopefully you've done that by now, and I did it, and I got 26.0296, but you know, we would be rounding that to 2 sig figs. So I do want to remind you, remember this number and this number here, believe it or not, have 2 sig figs. Two sig figs. Even though I know that's 0 at the end, I know, that's trippy, but it's not counting in the significant figures. There's only 2. So your final answer has 2 significant figures. Now, some professors are real fussy on significant figures. I think it's good to train yourself in that, especially if you're going down the science path. Okay? So, hope that helps. That is as far as we need to get. Good luck out there.